told that you can use dot patterns to illustrate distributive properties for operations on whole numbers. Write a number sentence to represent the pair of dot patterns. So what they're saying is we can use this grid to represent the distributive property. And they want us to write an equation or a number sentence that represents this scenario. So here's the equal sign right here. Make it larger. And we want to talk about how this side equals that. And what can we write? Well, I'm going to focus on the area. I notice here this is a 1, 2, 3, 4, 5 by 1, 2, 3, 4 set of dots. So it's a 5 by 4 set of dots, which is 20. And I'm going to make sure I don't lose track of myself, because no matter how I rewrite this, on this side I should still get 20 because they're equal. So how do we represent 5 by 4 here? Notice this line they're drawing. That line forms 1 and then 2 rectangles. So the distributive property would tell me that, oh, well, I take the area of each of these smaller rectangles and then add them up, I still get 20. How can I do that? Well, notice this one is a 1, 2, 3 by 4 rectangle. So 3 by 4. And we want to add that to this blue rectangle so we get the same area. That's a 2 by 4. And that's it. I've used the distributive property. This is 12 and that's 8. 12 plus 8 is 20. And how does this actually connect? Notice that we have 3 and 2 here, and that equals 5. So to jump from here to here, we took 5, these 5 dots right here, and split them in 1, 2 groups. So 5 can be thought of as 3 right here, plus 2. And in both cases, the height was 4. So we distributed and got this. Notice the 2 4s right here. That's because we multiplied 4 by both parts, by 3 and by 2. We did 4 by 3, that was this rectangle, and then 4 by 2. In other words, we took that 4 and distributed it or multiplied it out to each part. And that's what we're doing right here. And then we just add the parts together to keep the area. Alright, hope that helped.